Hi, everyone. This is Mistress Sweepy, Mistress of Tech, and welcome to another edition of my podcast today. We are here live in Lyons, Nebraska at Bill Hedges' studio, but this time we're not in the spaceship. We are in the projection room. So, as you can see, we've got all this lovely equipment behind us. And I've got a few friends here who wanted to tag along and check out the podcast. So, today we are going to be talking about the evolution of GPS and why it works, why it fails, and what the future holds for GPS. So GPS today, in this day and age, we all say GPS. Oh, let me just GPS, see where I'm going. Let me check my map. Let me GPS. Give me your location. I'll GPS it. GPS, we throw that word around like water, because it's typical. We all use one form of GPS and another, whether it's your little TomTom device in your car. I don't know if they make those anymore, or if it's your car has a built-in GPS system, or if you're like me, you still use a cell phone. So GPS is it's not going to go away. It's actually going to probably just keep getting better. So think about how often location shows up in your everyday technology. Like, for example, your maps, rideshare pickups like Lyft or Uber, food deliveries, tagged photos, tracking your packages, fitness watches, airlines, financial systems, emergency dispatch. I mean, the list goes on and on. GPS is so much heavily part of our modern life system that most people only notice it when they are actually looking at the GPS monitor and looking at what they see in front of them, or it sends them to the wrong location. That's like the only time we really focus on, okay, well, why did my GPS send me here? I wanted to go here. Other than that, it's like second nature. All right, I'm going here. Just plug it into your GPS and boom, you just go. But to understand why GPS feels magical, you have to start, you have to go back to the Cold War. Its roots goes back to 1950, specifically 1957, when scientists tracking the Soviet satellite Sputnik noticed the pitch on its radio signal changed as it moved. An example of the Doppler effect and that insight led American researchers to realize that satellites could be used for navigation purposes. The U.S. Navy then ran early satellite navigation experiments to help track submarines carrying nuclear missiles, showing that orbitable radio signals could help determine same real-time positions. So in the early 70s, the U.S. Department of Defense decided it needed a stable, robust navigation system that could support military operations globally. And the program became known as Navstar GPS, Navstar GPS. The first satellite launched in 1978, and the original 24th satellite system reached full operational capacity in 1993. What began as a defense system was designed for hard military problem navigations, timing, focus, coordination, weapon support. Now you have to remember they were carrying missiles, so timing was of the essence. You needed to be able to track these boats and these ships on real-time GPS. You couldn't have, I think they're real-time, or you couldn't have, you had to know. I mean, it was very important back then. It's also an important political backstory. GPS became broadly available to civilians after the 1983 shoot down of Korean airline flight 007, which had strayed off course into the Soviet airspace. And the President Ronald Reagan at the time said GPS signals would be made available for civilian use once the system was ready. Even then, military initially designed degraded civilian accuracy through selective availability, reserving higher precision for authority military personnel instead of civilians. They didn't feel like civilians really needed to have that kind of technology back then. But after the airline crash, President at the time, former President Ronald Reagan, made it, said made it where the signal could be used for civilian use as well. And I'm glad he did that, because now we know when we're on a plane, we know that the GPS is that the pilots are using the GPS to get ourselves from point A to point B. And GPS signals are help, and at the radio towers, they help us to get to that point without any problems or any issues. Well, we know that things happen, unfortunately. The Cold War that Cold War origin matters because it explains the personality of how GPSs are. It was built first as a strategic military infrastructure, not as a phone feature, not as a TomTom feature for your car or other navigation devices. It was strictly used for the military purposes. Then over time, we had other GPS features. We have, like, if you look at our phone, we have like the weather app that tells you real-time weather reports. There's also, this is funny, but Domino's pizza delivery tracker. You know, you can track when your pizza goes into the oven and then when it's ready, when they're on the way to deliver your pizza. So like GPS has far, far advanced from the Cold War days to present day. So it's definitely improved. Could still use some improvement. Any device can be improved. So how does GPS actually work? Well, the simplest version is this. Satellites don't see you in the camera sense. They broadcast radio signals containing the time and orbital information, and your receiver listens. So your phone calculates how long those signals took to arrive, turns that travel time into estimated distance from each satellite, and then solves for where you must be. That's complicated. I don't want to know that. I just want to be able to get from point A to point B. So a key point in timing, GPS is actually a timing system disguised as a positioning system, because the entire trick depends on measuring tiny signals for arrivals is from multiple satellites. So, for example, we have satellites in orbit. We have. I know people that have the Elon Musk's satellite for home internet. I mean, there's so much satellites up there that we're trackable. Doesn't matter where you go. We're trackable. Anyone can find us anytime they want. This is why satellite geometry matters so much. To get a full fix, your receiver generally needs signals from at least 4 satellites, because it has to solve for latitude, longitude, altitude, and the receiver's own clock error. With fewer satellites, positions become less reliable and impossible. You could have poorly arranged satellites and then it won't pick up your exact location. So the GPS space segment is a constellation in medium Earth orbit, about roughly 20,000 kilometers above the Earth, with satellites arranged across 6 planes, so users can see each 4 satellites from almost anywhere on the planet. So this is where the revolution becomes easier to appreciate. Your phone is hearing faint radio signals from satellites that each circle the Earth twice a day, and it's performing a fast calculation to estimate your location from timing differences from one location to another. So this is astonishing engineering, especially when it works in your pocket and while you're walking between buildings. Even if your battery is only half charged, it still will work. Now, an important correction from a common myth I want to mention. Satellites don't actively track your phone the way a cellular network does, or an app. GPS is mostly a one-way for the receiver. The satellite broadcasts and your device receives. When people say GPS is tracking me, they often mean that their phone's application, operating system, and mobile carrier or cloud service is tracking them. And they're sharing that data with the satellites so they can pinpoint exactly where you are and where you're going. Your phone also does not rely on GPS alone. In everyday technology, modern location systems are hybrids that combine other GPSs and satellites with a cell tower data. Wi-Fi positioning, motion sensors, maps, software predictions that make location seem faster and more stable and reliable. That's why even your position can appear immediately indoors, even when raw satellite reception is weak. You ever think about that? Even when you're indoors. The device is leaning on assisted methods in previous context. So the question, and I have this all the time, is that why do I lose GPS? Like when I was driving here to Bill Hedges' house, my GPS was lost. Why does that happen? If we've got all this technology in the sky and we get all these trackers watching us, how is it possible to lose GPS signal? The first reason is weak signal strength, obviously. GPS signals are very weak by the time they reach the ground, so roofs, walls, parking garages, trees, canyons, dense forests, all of that contributes to a weak signal for GPS. Because in essence, it's blocking the signal from reaching the ground, which is why your GPS gets lost at times. The second reason is multipath. That happens when the signal bounces off one building, metal, glass, or any other surface before reaching your phone, so that it takes longer. Once it bounces off, it takes longer to reach your phone. And what that happens is that the satellite is farther away than it really is, so by the time it gets to your phone, it's lagging and it can drop the GPS signal and the signal will get lost. And then also we have to take into consideration the atmosphere. GPS signal passes through the ionosphere and charged particles there before it hits our phone. So there's also that other process involved. So it depends on the kind of day too. Sometimes if you get a great day, it also can those ionospheres in the sky can also happen to have your GPS go down. It can even be a sunny day or rainy day. It doesn't matter on the precipitation. There's also human expectation. People often expect the little dot on your GPS map to mean exactly where you are, where your body is at that present time. But many consumer systems are designed to provide practical navigation, not centimeter level truth. For everyday use, getting you to the right lane, to the right location, the GPS was built for that, and that's its goal, is to get you from point A to point B with using the most efficient way to prevent you from having less mileage, to be more economic with your fuel mileage. It's just an amazing thing. GPS is just phenomenal. Another advantage of it is scale. One constellation can support billions of receivers without needing a direct subscription per device to the satellite themselves. This is a remarkable economic model, but the expensive part of it is space and public infrastructure. GPS is also very precise. What once required military systems and specialized equipment became a basic feature in consumer electronics, which means that transformed navigation from a skill into an ambient service. So the map in your pocket that you have, whether it's a map like your GPS or even like at your TomTom or any other form of GPS service, the map, it reduces friction, it allows people to pinpoint where you are, especially like, say, for example, you got into a car accident, you're on a road where the signal is weak, but your GPS is still there. You can give them your coordinates on your phone. This is where I'm at. They know to get help to your location where you are. So even though sometimes signal strengths can be weak, GPS is also a lifesaver, and it can save lives if it's working properly. So some of the aspects, with some of the negative aspects of GPS is that it the signal strength can be weak, and again, it just depends on where it's bouncing off of. You have those ionospheres in the sky. It depends on where your location is. If you get trees, buildings, glass, metal, that signal, by the time it gets to your device, it can cause your GPS to get lost, your signal to get lost. It also raises concerns about privacy, and that's another issue, especially in this day and age. Is some people don't want to be tracked. We don't want our GPS. Some people will actually turn off GPS on their phone. They'll turn off complete tracking on all of their devices, even their computers, because they don't want to be tracked. And while it does help, you have to remember GPS. Your phone relies on more than just GPS. There's the apps. There's the cell phone towers that pings you and pings your device. So you can say that you don't want to be tracked, and you can shut off everything on your device and your electronics, but you can still be found. It's not foolproof. It unfortunately, that's the way it is. Hopefully someday they'll find a way to fix that. So let's talk about the future of GPS. So the future is in my opinion, is that it's going to become more advanced. We're going to have more avenues, more ways for us to be tracked. Signals, one major direction is that multi-constellation and multi-frequency positioning, where devices can not only use GPS, but signals and correction methods to reduce errors from the ionosphere and improve resilience. So they're trying to find a way where they take the science of it and try to make it where they can avoid GPS drops, where they can try to find you. Even on a cloudy day, rainy day, sunny day, they can still try to find you. And they can also, for you as a consumer, to get from point A to point B without having to lose your signal. Another one is improved modeling. Google research and the related Nature paper describe using data from millions of phones to better provide a better GPS system for everyone to use, for consumers to use as well, with location accuracy. Indoor positioning is another option as well. GPS struggles with inside buildings, so future systems are likely to rely on more Wi-Fi, more Bluetooth, and more computer vision, as well in some cases 5G supported architectures to bridge outdoor and indoor navigation systems. So the trade-off is indoor systems often require more infrastructure, calibration, cost, and privacy management than a GPS does outdoors. So there's also that cost factor involved, but it's something I'm sure that, they will get that figured out. 5G may help too, but it has its limits. Some industry sources argue 5G can theoretically support very high indoor position and accuracy under right conditions, but again, that's also in work. So the long-term future is likely not one winner, but maybe layered locations. Outdoors, satellites remain foundational. Indoors, short-range systems can take over. There's a lot involved in here, and we can have a discussion for hours about this, but the long story short is that the next revolution in location may be less about a single new satellite system and more about making all of these systems invisibly and securely working together as one. And again, GPS, when I speak about GPS, I'm talking about it from a consumer standpoint. Right now we use GPS. GPS is part of our lives. If we're in a place we don't know, or if we need directions, it can take us from point A to point B. That's the great caveat about it. The other negative aspect of it is you're being tracked. And you can turn off every tracking device on your phone. You can go through your apps and remove, location sharing and all that, but you're still being tracked. Your data is still being shared. It's It knows where you are, and you can tell by when you do a search. Like if I do a search on my phone, it's going to pull up information where I'm at right now. It's going to pull up every store, every location, anything in my area, even though this is not my home location. It doesn't matter. I have everything turned off. It's still going to do it. It's just the nature of the beast. I hate to say it. So, and maybe this is why GPS remains such a compelling story for most of us. It's because it's not just a convenience feature. It's a Cold War invention that escaped its original mission, became part of our system in this modern civilization world. Every time the blue dot snaps into place, you are watching military history. Orbital physics, atomic timing, and consumer design all collapse in a single moment of certainty. So on that note, I just want to let people know that, you know, there are going to be more improvements in GPSs, and it's hard to turn everything off and not be tracked, but unfortunately we are going to be tracked. But I know that I believe in the future, in my opinion, that there will have more options, and I'm hoping that it's like that. So on that note, again, thank you for tuning in. I appreciate it. I hope everyone has a great day, and a kiss to everyone out there. Please be kind to each other, and I will talk to you later. Bye.